So today we are going to be talking about predicting products of chemical reactions. And when we go to predict products of chemical reactions, what we generally end up finding is that it's a series of steps that are the same over and over and over again. One of this series of steps that's the same is the idea that we use the reaction templates that we learned about the last time. And those reaction templates that we learned about the last time are designed to help you predict what the product is, but also identify the type of reaction. So in this case, the reaction template allows us to identify the type of reaction and then also identify the products that are present. The next thing, once you've identified the products that are present, you always want to check their charges and crisscross them down. And if it's a single replacement reaction, we'll use the activity series of metal to identify if the reaction occurs. If it's double replacement, we'll use the solubility rules to identify if the reaction occurs. And then lastly, we would balance the proper written equation. So in this case, we have two examples that we're going to talk about when we talk about synthesis reactions. And I know that this is a synthesis reaction, and as a result of knowing it's a synthesis reaction, what I'm going to do is I'm going to use the synthesis reaction template from our last lesson, which was AX or A plus X makes a X as a product. So what that ends up looking like is, in this case, I have A, which is hydrogen, and chlorine, Cl, which is my X. So on the product side, I would have H and I would have Cl. Now note that what I haven't done here is I didn't bring along these subscripts here. And that's because I have to check the charges of these particular elements. So we know from the periodic table that hydrogen is a +1, and we know from the periodic table that chlorine is a -1. So when we crisscross the charges down, we get H1 and we get Cl1. And we know that in this case, we don't have anything to simplify, so the actual product here is just going to be HCl. Then the last thing that we have to do is balance this reaction. So on the left side, I have hydrogen and I have chlorine. And on the right side, I have hydrogen and chlorine. And I see that on the left side, I have 2 hydrogens and 2 chlorines. And on the right side, I have 1 hydrogen and 1 chlorine. So then what I'm going to do is, to balance this, I'm going to put a coefficient of 2 here, which will give me my 2 hydrogens and my 2 chlorines. So this reaction is a synthesis reaction where 2 things become 1, and those 2 things were elemental hydrogen and elemental chlorine, becoming HCl, which is hydrochloric acid. The next example here is aluminum and chlorine reacting. And again, our reaction template is A plus X makes AX. And so in this case, we're going to grab the A, which is aluminum, and we're going to grab the Cl, which is chlorine. Now again, I'm not going to bring this 2 across because I have to go back and check my charges. Aluminum has a charge of +3. Chlorine has a charge of -1, according to the periodic table. So when I crisscross those charges down, I get Al1 Cl3. So this is going to be correct when it's Al1 Cl3. So the last thing we have to do here is balance this reaction, which I have aluminum on the right side and chlorine on the right side, and I have aluminum and chlorine on the left side as well. So 1 aluminum, 2 chlorines on the left side, 1 aluminum, 3 chlorines on the right side. Looking at this reaction, aluminum is balanced and chlorine is not. The odd-even hint was going to come into play here. And with the odd-even hint, I'm going to take the subscript behind chlorine over here and put it here, and the subscript behind chlorine over here and put it over here. And when I do that, on the right-hand side, I get 2 aluminums and 2 times 3, which is 6 chlorines. On the right side, I get 3 times 2, which is 6 chlorines. So lastly, it looks like my aluminums are not balanced, so I'm going to put a coefficient of 2 here. and now everybody's happy and balanced. So that's predicting products for synthesis reactions. So what we're going to do is we are going to go and I'm going to make a video for decomposition reaction next. So if you have any questions, refer to this video. Remember, the big hard thing is here to check your charges and crisscross them down.